Welcome back again to my YouTube channel. In today's video, we're going to have an analysis of the chemistry practical alternative A. So I want you to watch this video to the end as I introduce my mommy to guide me through most likely questions you might actually see in this forthcoming exam. With no further ado, let's get right into the video.
Welcome to part B of question number 1. The question is already there. This time A is a solution containing 3.58 grams per dm cube of HCl. B is a mixture of sodium hydrogen triisocarbonate 4 and sodium chloride, meaning that B is an impure base containing 12.0 gram per dm cube of solution. Equation for the reaction is HCl reacted with NaHCO3 to give us NaCl plus CO2 plus water. Then B say from your results and information provided above, calculate Roman figure 1 concentration of A in moles per dm cube. Roman figure 2 concentration of NaHCO3 in B, because B is a mixture, in mole per dm cube. Then Roman figure 3 concentration of NaHCO3 in B in grams per dm cube. Remember, B is a mixture, which is an impure. Then IV percentage purity of the base, which is NaHCO3. Then V says the mass of sodium chloride in the mixture, or they can ask it as the mass of the impurity, because you can see that sodium chloride is acting there as impurity because it never took part in the reaction. What took part in the reaction is NaHCO3. Then VI says percentage impurity in B. That means you are going to find percentage impurity of the sodium chloride in B. Then question C, if they will ask you, and I'm sure they will, state the reason why sodium chloride did not take part in the reaction. So you need this information to help yourself. So we are going to start the calculation without wasting time. Roman figure 1 says that we should find the molar concentration of the acid, but the acid was given in gram per dm cube, which is mass concentration. We are going to use the formula mole concentration equal to mass concentration over molar mass. So we are looking for this. We have mass concentration as 3.58. Then what is the molar mass of HCl? Take note, this. H is 1 given plus 35.5. You bring it down, so it is 3.58 divided by 36.5. Like I said in part A, you don't need to put unit, just leave it the way it is. But if you have to put unit, let it be correct unit, grams per mole. Then the final evaluation is 0.0981 mole per dm cube. Exactly 3 significant figures. So we've gotten the molar concentration of A. Then question 2. We should find the molar concentration of B. Of course, we need to find the molar conc of B because B is an impure sample. So this time we are going to use the formula CaVa over CbVb equals Na over Nb. You substitute correctly 0.0981. Remember, your VA remains your average titer value, which is 24.23. Divide by, we are looking for CB, and the volume is 25.00. Our mole ratio for this exam, as long as this acid and base are given, remains 1/1. For doing this is 1 mark. For correct substitution, then you now make your CB the subject of your formula for another 1 mark. Step by step. Times 1 all over 25.00 times 1. Another 1 mark for correct, for making CB the subject of your formula. Then finally, you evaluate. The final evaluation is 0.0951 mole per dm³, meaning that the actual B that took part in the reaction is this amount in mole. So if you convert this to mass concentration, you will get something less than this 12 here, because this 12 contains this NaHCO3 and sodium chloride. Can we go to the next question, where they want us to find the mass concentration of the B, which is the NaHCO3. That is question number 3. Now, converting this to mass concentration, we use our normal formula, which is the mole concentration equals to mass concentration over molar mass. Remember, we are making molar mass mass concentration the subject of our what? Formula. You now say mass concentration equals to the mole, which you have already, 0.0951. Then we are going to calculate the molar mass of the base this time, because we are working with the base. And the base is NaHCO3. Can we bracket it? Na is 23.0 unit plus 1 plus 12 plus 48. And that will give us 84. So we continue. Concentration. Mass concentration is equal to 0.0951 times 84. And what's the answer? You write the answer. The answer is 7.985. To treat significant figure, 7.99 grams per dm³. That is the pure. This is the actual base that reacted, not 12.0. So this is the mass of the pure. IV says percentage purity. That is the percentage by mass of the pure in the mixture. It has a formula. So IV says percentage purity. That's the formula. Is equal to mass of the pure, which we have gotten already, over mass of the mixture, which is the impure. Mass of the impure times 100 over 1. That is the formula. So you have to substitute into the formula. Mass of the pure is 7, exactly what you have is what you are going to use. If it is wrong substitution, no score. 7.99 over the mass of the impure is there in the information provided, which is 12.0. 12.0 times 100 over 1. Then what is your percentage pure, which is purity? That's the answer is 66.58%, but you have to bring it to three significant figures, which is 66.6%. That's the answer. Please make sure you always express your answers to three significant figures with correct units. V says you should find the mass of the sodium chloride in the mixture, or they will say find the mass of the impurity, because sodium chloride is acting there as the impurity. So how do you get the mass of the sodium chloride? Formula: mass of sodium chloride, which is the impurity, in case they put it that way, is equal to mass of impure minus mass of pure. That's it. You bring this down, make sure you bring it down, very important. Then you say 12.0 minus 7.99. Keep bringing it down so that you state the subject of what you are looking for. It's very important. And the answer is grams per dm³. If you put ordinary grams, you have lost that mark, because this impurity is with the pure in 1 dm³. So the correct unit is gram per dm³. Thank you. So we go to the next question. The next question, you are expected to find the percentage impurity in the mixture. In case you are asked, the formula is percentage impurity is equals to mass of the impurity. Mass of the impurity over mass of impure times 100 over 1. You bring it down as usual. The impurity is 4.01. Mass of the impure is that 12.0 times 100 over 1. Then what's your answer? 33.416, which is 33.4%. That's the answer. Meaning that you know what you have done. Part of the question, in case you are asked, you have to state the reason why the sodium chloride, which is impurity, never took part in the reaction. It's a chloride salt, very stable, and the chloride salt cannot just react with anyhow acid, which is a dilute HCl. So it will not take part in the reaction. It is so stable and cannot react with the acid given. That's the correct answer. This is another question under question 1, and I tagged it part C. Let's look at it and get it solved. It will benefit you a lot. I go. A is a solution containing 1.79 grams HCl per 500 cm³ of solution. B was prepared by diluting 50.0 cm³ of a saturated solution of NaHCO3 at room temperature to 1000 cm³ with distilled water. From equation for the reaction is already the same. I've been using the same equation, sorry. Then B part of it says, from your results and information provided above. What is your result? Your titer value. Information provided above. This time is another information. This is what they say about your acid, and this is what they have told you how the base was prepared. That's your information, which is very important. Then, remember figure 1. Calculate the concentration of A in moles per dm³. Remember figure 2, concentration of B in moles per dm³. And 3, solubility of NaHCO3 in moles per dm³ at room temperature. Then IV, the mass of sodium hydrogen carbonate 4 that would be deposited if 1 dm³ of the saturated solution was heated to dryness. That's a very good question. It's so funny, but it's very simple. They just want you to convert whatever you are going to get at your solubility to convert it to grams per what? dm³. So please take note of that. Then finally, the V, the mass of salt formed during titration. Just like I did it in part A, the volume of carbon 4 oxide liberated if 1 dm³ was used, and or the volume of carbon 4 oxide liberated during titration. So we're going to solve this, but I want you to use this to also figure out the other one in case they use 1 dm³. You use the conc in 1 dm³. But this one is interesting, so I have to do this one for you. Can we start? Let's look at question number 1. The conc of A in moles per dm³. Remember in the question they say that 1.79 grams of A was dissolved in 500. So they want to give us the conc in gram, but not yet in gram, because 500 is not up to 1,000. So we are going to make it up to 1,000 before we now convert it to mole per dm³. I start. 500 cm³ of A contained 1.79 grams of HCl. Therefore, 1,000 cm³ of A will contain X. Cross multiply 500 times X equal to 1,000 times 1.79. Therefore, X is 1,000 times 1.79 divided by 500. Then what is X? Just like multiplying this by 2, and that will give you. So we have succeeded in getting the mass concentration of A. But unfortunately, that's not what they asked us to do. We are going to convert it to molar concentration, which is mole per dm³. So using the formula, concentration in mole per dm³ equals to mass concentration. Let's just put direct. 3.58 divided by the molar mass. Molar mass of what? Molar mass of hydrochloric acid, which is calculated as 36.5. Then what is the answer? Conc in mole of the acid per dm³ is 0.0981 mole per dm³. So that would be evaluation is 0.0981 mole per dm³. That is the conc of what? A. Okay, sorry, the one I just calculated is the first question, which is concentration of A in moles per dm³. Like I said, from the information provided, they say 1.79 is dissolved in 500. I need to make it up to 1,000 to get the actual concentration, which I have already done. Then I have to convert this mass concentration to mole concentration using the formula, and that is the answer. I want to go to number 2 that says concentration of B in moles per dm³. So we are using the formula CAVA question, which is conc of B in mole per dm³. Good. This conc of B in mole per dm³ is the diluted B that was used in titration, not the concentrated B. Remember, B originally was obtained from a saturated solution which was diluted to give you the B that you use in the what? Titration. So this count of B in mole per DMQ happens to be the diluted B that you use in the titration. And that is what I want to look for. And that is CAVA over CBVB equals to NA over NB. Okay, to substitute, I've already gotten CA to be 0.0981, and my VA, like I said before, you keep using your average titer, 24.23 divided by CB times 25.00. Now from the balanced equation, you have to check your mole ratio, which is still 1:what? 1. For this exam is 1:1. I repeat, as long as ACl and sodium hydrogen triisocarbonate 4 are given. So making CB the subject of your formula, it is 0.0981 times 24.23 times 1 all over 25.00 times 1. Therefore, CB is 0.0951 mole per DMQ. This is the B used in the titration. Then question number 3, they want you to get the concentration of the saturated solution. So solubility and concentration are the same. The difference between the two is that solubility has to be expressed at the temperature, either room temperature or at a given what? Temperature. So it is the same thing with what? Concentration. So that means the solubility I have to look for now is the original concentration from where the B that was used in titration was prepared from. Meaning that I'm using dilution formula. I'll use dilution formula, which is number what now? III. I'm solving for III, which is solubility. C1V1 equal to C2V2. Remember, C1 is the concentration of the concentrated solution. That's what C1 stands for, which is the solubility. Then V1 is that volume that was obtained from the saturated solution. Is there in your question? They took 50 cm cube from the saturated solution to dilute it to 1000 cm cube with distilled water. So V1 is that 50 cm cube used for the dilution. Then V2 happens to be the one that they have already diluted, the one you used in your titration, which is that your CB. So this C2 is your CB, which is 0.0981 mole per DMQ, the diluted base. Then V2, remember, this diluted base is the 1000, which is 1 DMQ. So your final volume is 1000 cm3. Remember, you took 50 from the original concentration, which is the saturated solution, to make it up to 1000 with distilled water. So the volume is 1000. Can we find the C1 now? Looking for C1, or rather making C1 the subject of the formula, it will now be C2V2 over V1. Then what is our C1? Our V2 is 0.0981. Our V2 is the 1000, while our V1 is the 50 that you measured from the saturated solution. And your C1 is 1.0981 4.90 mole per dm cube at room temperature. It goes with temperature. That's why it is called solubility. That's what makes it different from concentration. Because solubility is the maximum amount of the solid that can saturate 1 dm cube of the solvent at that given temperature. So this is solubility, which is our original concentration. Remember, it is a saturated solution. We have gotten the solubility. It's not too difficult. It's very easy. Can we go to the IV, which is the mass of the NaHCO3 that will be deposited if 1 dm cube of the saturated solution was heated to what? Dryness. This is an indirect way of asking you the solubility in grams per what? Dm cube. So we are using our conversion formula, which is a mole concentration equals to mass concentration over molar mass. Our mole concentration is 1.90. Our mass concentration we don't know. You can target X. Then what is the molar mass of the sodium hydrogen trioxocarbonate 4? You got it before to be 84.0. Then making X the subject of your formula. So what is X is now, like I always say, you put it to 3 significant figures. But I can still permit me to still put the unit gram per what? Per dm cube at room what? Temperature. But let's get it properly written. So it have to be 160. Why is it 160? I have to stop here as my 2 significant figure. This is already 10, you call it 0, add it to here 6, then 1. So this is 160 grams per dm cube. At what? Room temperature. That's what we want to see. And that is it. So we've gotten the mass of the base that's supposed to be deposited when heated to dryness. So finally, for this question, and finally for this number 1 question, which I know that God willingly you perform excellently well. Let's find the mass of the salt formed during titration. This is not like this one is just mass concentration, but this one is the mass produced. So we're going to face this from the balanced equation. This is under the topic called stoichiometry. So to solve the last one, which is the mass of the salt formed during titration, because they say during titration, before I go to the balanced equation to start my calculation, I have to find the amount in the 25 cm cube of the base used, as usual. But that is the amount I have to use to get the mass of salt. Remember how we did it for carbon 4 oxide volume. So NB equals to CV over 1000. Therefore, NB, the C is 0.0951 times the 25, which is my area of interest. I want to know the amount in 25. Divide by 1000. Therefore, NB is 0.00237 mole. That is the amount in the 25 cm cube of the base used during the titration. And the mass of the salt formed will depend on the amount of the base used. But if we had used 1 dm cube of the base, we should expect large quantity of what? Mass of the salt. So, can we go ahead now to go to our balanced equation? I start from the equation. 1 mole of NaHCO3 produced, remember this is stoichiometry, Produce how many moles of the salt? 1. You can see 1, which is 1 mole of the salt. And the salt there is sodium chloride. Therefore, this is what I have to use. 0.00237 mole of NaHCO3 will produce X cross multiply. That will give me 1 times X equal to 0.00237 times 1. Therefore, what is X? X is 0.00237 times 1 divided by 1. Therefore, X is 0.00237. This time the answer is in mole. Then they ask me for mass. It's good to work with mole and convert finally to mass. Like we worked with mole in terms of the volume and we converted finally to volume. So this is the mole of the salt. Then what is the mass? The mass is the mole obtained times the molar mass. Molar mass. Okay, the mass. What is the mole? 0.00237 times 58.5. One will ask me, how did I arrive at 58.5? Let me take a little bit. This is NaCl. Na is 23 plus 35.5. And that will give you 58.5, which is the molar mass of the salt. So, what will now be the answer? You now say mass is approximately 0.139 grams. You are not supposed to say grams per dm cube because the amount of base that gave you this mass is not in 1 dm cube. The mass of the base is in 25 cm cube of the base you use during your titration. Thank you. But don't forget, supposing they change this question and they now ask you to find the mass of the salt form, if 1 dm cube of B was used, please, you don't need to go and start trying to get the amount in 25. Please use the conc of B, and the conc of B remains 0.0951. That is what you use in place of where I use the amount. Where is that now? Here. I say 1 mole of this will produce that. Therefore, you will not use this one again. You use the main conc to get the main mass. The same method. Thank you and God bless you.
Thank you so much for staying and sticking to the end of this class. If you have any other question you want us to solve for you, or if you have any question at all, you can drop it in the comment section. I will see you next time in the next one. Bye for now.